Okay? So here we have the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. Okay? Now, we can derive those things, and I'll actually work through some of that later on. Okay? But let me show you a little thing here with the sine and cosine that's actually really helpful, and we'll actually use it later on when we get to integration as well. Okay? But on the unit circle, the x-coordinate is what? No, the x-coordinate, all the x-coordinates are which of?
What do you mean?
Oh, there's cosine.
They're the cosines of the angles, right? Okay? So I'm going to go ahead and put a positive cosine here, and I'm going to put a negative cosine here, kind of like the x-axis, and the y-coordinates are the sines, right? So I'm going to put a positive sign up here and a negative sign up down here. Okay? Now, the reason why I do this is going to be really helpful to help you memorize this or remember this. If I rotate clockwise, okay, the rule we just saw, the derivative of sine is cosine. What's the derivative of cosine? Negative sine. What do you think the derivative of negative sine is? And the derivative of negative cosine is? Sine. Okay? So if we're taking the derivatives, the derivative of sine x is cosine, and so on. If you rotate around this little circle clockwise, it'll tell you what all the derivatives are. And here's a little spoiler. When we get to integration, guess what we're going to do?
The unit circle.
Rotate backwards.
Oh no.
Okay? The integral of cosine is sine. The integral of sine is negative
I don't know what
cosine.
an integral is.
That's okay. We're not there yet. Okay? But that's a little trick I like to use to help us remember. Because I will say this: it's very easy to forget which one ends up negative. Okay? The derivative of cosine is a negative value. Okay? Now,
And then change that. Bless you.
so let's go ahead and look through how we would do some of these with the product rule, and then we'll do some practice with this as well. Or not product rule, the chain rule. All right, and I give you these first two examples specifically because they're so similar. But you got to be really careful, okay? So guys, check this out. We have the cosine of x squared, or we have cosine of x that is squared, okay? You've got to pay attention to, is the x being squared or is the cosine being squared? And it makes a big difference in how you do the chain rule, okay? Now, if you remember what we were looking at previously, we wanted u to be the inner function, okay? So we have this inner function u. What's the inner function on cosine of x squared? It's the x squared, okay? It's the x squared. We also saw the g of u was the outer function. What's the outer function here? Yeah, the cosine of u. All right, so u prime is 2x. You guys know that by now. G prime of u, the derivative of cosine is a negative sine of x. Okay? And then we need to multiply, or sorry, not negative sine of x, negative sine of u. And then we need to substitute back in, because we don't want our answer to be in terms of u. We want our answer to be in terms of x. Okay? So this is negative sine of the x squared. And now we simply need to multiply the two things that we just found together, And that will give us dy dx equal to a negative 2x sine of x squared. We simply took the negative sign, we multiplied it by the 2x, and we get our derivative. The biggest challenge with these is to make sure that you properly identify inside and outside. Okay? And that's not just with trig functions, but that's with all of these chain rule types of problems. Think about it as though you were evaluating the function. The outer function is going to be what you would end up doing last. Okay, so for example, if I had, say, x equals pi over 3, okay? If I were finding y equals cosine of x squared when x was pi over 3, I would be squaring the pi over 3 first. So I'd have pi squared over 9. I would do that first, and then I would take the cosine. Okay? That's the first one. The second one, if you think about what you would do first, I would be taking the cosine first. The cosine of pi over 3 is a half. Okay? And then I would be squaring it. Okay? So then I would take that and square it, and I would get 1/4. Okay? So you got to be really careful with your order of operations in these cases, because in this case, all right, because the square is what we would do last, that's going to be your g of u. So u squared is our outer function here. What we did first, we took the cosine of pi over 3 first. We're going to be taking the cosine of x first before we square it. Okay? This is why I gave you these two examples right off the bat, because I want you to make sure that you make this distinction. So now that we've identified those, the derivative of cosine x we have a rule for. Okay? So u prime is simply a negative sine x. Okay? G prime of u, okay, the derivative of something squared is 2 times that something. Well, what's the something? It's cosine. Alright, so this is 2 cosine x. Okay? So we have 2 cosine x. So now I can find dy dx by multiplying these together. So I have u prime negative sine of x times g prime of u. So times 2 cosine x. And I can simplify that. It would be a negative 2 sine x cosine x. Okay? And you can be done at that point. Alright? Now, before we go on to the next example, I do want to point out one thing that does make these tend to be a little bit tricky when we're dealing with trig is how far do we simplify? Okay? You may remember, although it's been a little while, you may remember our trig identities. Okay?
Yeah.
Those are still around. And it is possible to simplify this further. Okay? I could keep going. And you guys remember what 2 sine x cosine x is?
Oh, negative. Wait, no. Is it negative 1?
That was one of our double angle formulas.
Oh, man.
Okay?
We didn't remember.
So that we could actually simplify down to sine of 2x. Okay? That whole thing simplifies down to negative sine of 2x. Because 2 sine x cosine x is our double angle formula, okay? So guys, listen, all of that stuff still applies here.
So do you expect
Okay.
us to simplify down to that?
No, not, and that's why I said, guys, you can be done at that point. However, this is what happens, okay? Sometimes we have to solve equations where the derivative equals something, okay? Well, if you have the derivative equal to something, and you're trying to solve that equation with trig, you can't solve a trig equation typically if there's two different trig functions in it. You've got to get it all in terms of one. Okay? So this is where what we did last year in pre-calc honors, solving trig equations and using identities and all those proofs that you did, that comes into play here. Okay? Because we want to, let's say we want to find, hey, where does the derivative equal 0? Well, where does sine x cosine x equal 0? We want to get that in terms of one trig function. Okay? So be aware of that. You don't have to go too far unless you have to, but sometimes you have to. Okay? Or sometimes you may be asked to show that the derivative equals something. And you get down to negative 2 sine x cosine x, and you think you're done, but they're like, but they have it as show that the derivative equals this. You may have to go a little further. Okay? So, that I just want you to be aware of. Okay? Alright, let's check out our last example and then we'll do some practice here. We've got y equals sine of x squared minus 3x plus 5. What's the u in this case?
That equation. X squared minus
Yeah, x squared minus 3x plus 5. Okay? So that means u prime equals what?
2x minus 3.
2x minus 3. Okay? Is everyone with us?
Yes.
Some of you are being awfully quiet.
I mean, yes.
Okay? Alright. G of u. What is G of u?
Sine u.
Sine of u. There we go.
That just becomes cosine u.
So, G prime of u is cosine u. Whoop.
Which becomes
Cosine u, which is
cosine x squared.
very good. Okay. Good. Okay. And now these we just have to multiply together with our chain rule. dy dx is, make sure you put parentheses around the 2x minus 3. So 2x minus 3 times cosine of x squared minus 3x plus 5. Okay? The parentheses are important. Okay? Also, just out of habit, I would put anything you're multiplying by the trig function in front of it. Okay?
Okay.
Rather than make it cosine of x squared minus 3x plus 5 times 2x minus 3, just to avoid any kind of confusion as to what's inside the cosine and what's outside. Okay? So,
And that's it? We just need
I want to derive our other trig functions as well. Okay, now this is one way of deriving it. There are other ways as well that you can use, okay? But here we have y equals cosecant x. Alright, y equals cosecant x. Now I gave you a hint on this first one. Cosecant x is sine to the negative 1. Alright, which, by the way, do not confuse that with the arc sine. Alright, the inverse sine. I know the notation is similar, but please make sure you distinguish. Alright, so remember, if we don't know how to take the derivative of something, we're going to see if we can rewrite it. So we have sine to the negative 1 so what would the u be in this case?
sine x.
Sine x. What's g of u? u to the negative 1, okay? So if dy dx is u prime times g prime of u, using our chain rule, what's u prime?
U prime is cosine x.
Come on, everyone. Cosine x. U prime is cosine x. I gotta just start calling on people since you guys are so quiet. Gary, you know this. What's the derivative? What's g prime of u? The derivative of u to the negative 1.
It's gonna be.
God bless you.
Cosine x.
That's the u prime. What about the g prime? The u negative 1. You can keep it in terms of u for right now.
It's gonna be sin x. Sin.
Forget about the sign for right now. If I have something to the negative 1 power, what's the derivative? Oh, yeah, negative u to the negative 2, okay? Negative u to the negative 2. So, guess what? We have a negative, and it's going to be a cosine x over the u squared. Well, the u was sine, so this is over sine squared x. Okay? Now, for the actual rule that you would memorize if you were in AP Calc, you don't have to have this one memorized, but it comes in handy. We would actually split this up. So I would rewrite that sine squared as a sine times sine, and make this 1 over sine times cosine over sine.
Which is so tans. Or cotangent.
Okay, so what's 1 over sine?
Cosine times.
Cosecant. And cosine over sine is?
Cotangent.
Cotangent. Okay? So the derivative of cosecant is negative cosecant times cotangent. Okay?
Well, what do you know?
So
that's just what you have to memorize.
That's what you would. It wouldn't hurt to memorize this one, but in SL they don't require you to memorize this. So cosine is negative sine. And what was the derivative of tangent?
Negative secant squared?
No negative.
Just secant squared?
Yeah, just secant squared. And actually I'm doing this because I want to show you something at the end with all 6 of these, okay? Let's work through secant, okay? In fact, you guys work through secant. Take a minute here. Try to figure it out on your own. Okay, so how many of you got secant times tangent? Alright, a couple of you? Alright, listen guys. This is the kind of thinking you got to be able to do, alright? You may not have to memorize the derivative of secant, but you should be able to use the rules that you do have memorized to figure it out, okay? So, using the same properties that we did before, I'll unfreeze the screen so you can see this.
Oh, you did.
There we go.
You probably did it like 10 seconds.
So, but guys, notice the similarities here, and this is where we have a process, follow the same process, it just has a slightly different content within the process. This is what you do when I give you an example problem in class, and then you go home and work on your homework. You have similar problems, you just have to follow kind of the pattern if you're stuck. Alright, so here, cosine is the u, g of u is u negative 1, the derivative of u negative 1 is negative u to the negative 2, the derivative of cosine is the negative sine, okay, so there's the u prime, and here's the g prime of u, okay, that we're multiplying together. Well, u is cosine, so this is a negative 1 over cosine squared. Alright, so we have negative sine times a negative 1 over cosine squared. So negative over negative is positive, and I'm going to clean this up a little bit using some identities, just like I did on the first one. I split this into a 1 over cosine times a sine over cosine, and you'll notice 1 over cosine is secant, sine over cosine is tangent. So the derivative of secant is secant times tangent.
Just to make sure, so on our quiz on Thursday, would we lose points if we don't simplify the secant times tangent?
As long as you made it positive,
Okay.
you could stop there,
Alright.
you know.
And then just to make sure, you used the chain rule right after you did the derivative of cosine.
Yeah, right here, I'm identifying right here that I need to use the chain rule. I have a cosine inside of a negative 1 power.
Okay.
So the inside is the cosine, the outside is something to the negative 1. So derivative of cosine is the negative sine. The derivative of something to the negative 1 is negative 1 times something to the negative 2. Okay? And now I'm just plugging in the cosine again. And that's a negative 1 over cosine squared. So that's where this came from. Okay? So again, the algebra you got to be careful with here. Alright? And then finally, tangent. Notice here, for tangent, I'm going to use, or cotangent, I'm going to use the same process. Cotangent is tangent to the negative 1. So, again, my outer function is u to the negative 1. The inside is tangent. Okay? Now this one is a little bit different because, okay, derivative of tangent is secant squared. We've got the negative 1 over u squared. So that's a negative 1 over tangent squared. And secant squared is a 1 over cosine squared. Okay? Well, 1 over cosine squared times negative 1 over tangent squared. 1 over tangent we already know is cotangent. So 1 over tangent squared is cotangent squared. And you guys know cotangent is cosine over sine. Alright? So cotangent is cosine over sine, so cotangent squared is cosine squared over sine squared. And notice now my cosine squareds cancel out. I have a negative 1 over sine squared, which is a negative cosecant squared. Okay? And those are the derivatives of all 6 trig functions derived from our first couple and the chain rule. Okay? So, just to kind of put all of this together, we have the derivative, of cotangent is negative cosecant squared. We have the derivative of secant is secant times tangent, and we have the derivative of cosecant is a negative cosecant times cotangent. Alright? Does anyone see any patterns with the 6 of these?
I can all be deducted with one equation.
Well, all 3 of these, we basically did use the same process, the same equation. But look at the results here. Derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent secant squared. Derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant tangent. And derivative of cotangent is negative cosecant squared.
I don't know.
What do you notice?
Interesting.
What do you see? It doesn't have to be anything incredibly insightful. Just okay.
Times secant.
X's.
What?
Times secant multiplied by secant.
Okay, the middle one's multiplied by secant. about 3 of them are? Noah, how about you?
I don't know.
Both.
Okay.
I'm trying to find.
Both tangent and cotangent of a square.
Okay, there's something we could see. Tangent and cotangent both have something squared.
It's both.
And by the way, you remember your Pythagorean identities? Sine squared plus cosine squared is 1. 1 plus tangent squared equals secant squared. Tangent and secant go together. They went together in the Pythagoreans. They go together here, both in derivative of tangent, and look, derivative of secant is secant times tangent. Those two are connected there. Also, hang on real quick. Also, 1 plus cosecant squared is cotangent squared. Okay? Or I'm sorry, 1 plus cotangent squared is cosecant squared. Cotangent, cosecant go together. Notice all the trig functions that start with C. What do all those have in common?
Sine, cos. They're both related.
Their derivatives are all negative. So if it starts with C, the derivative is negative. That's another thing, because that's what people mess up a lot on these, is which ones are positive, which ones are negative. If it starts with C,
C is
the derivative is negative. Okay?